Yo, what's up, everybody? Welcome back. Today we are working on our map. And today's topic is trying to plan trips using the bus. So, context for this project is I sometimes try to navigate around my city. This is my city, Vancouver, because sometimes I want to go from one place to another place. Rarely, I stay home most of the time, but sometimes I go out, right? And in that case, I might take the bus and I might ask Google to say, I might say, like, hey, this is like somewhere I don't usually go. Like, what's the fastest way to get there? And it will give me some like batshit crazy options, in my opinion. It will say, like, take 2 transfers and wait for this bus to take you 5 blocks instead of just walking. And it assumes that the buses are going to be on time, and so like it's going to say, like, okay, it'll schedule transfers that are like too close together. And I think that I can do better, right? Because we have hubris on this channel. We believe that we can do anything, everything, even if we can't. And so that's what we're working on. Is we have like this like rudimentary path planner, right? So red line here is showing like just like using any street that it can get there. We can do things that we can say, like, hey, I don't want to turn so much, so like I can increase the turning cost to like make it trend towards going straight. I can do things like say, I don't want to take busy streets. So if I like look at this thing, I can be like, hey, color all busy this type of street orange, and then I can say, like, if I want to walk, like, how do I do this? If I want to walk from like here to here, right? It'll like take the orange line, but then if I say, like, hey, look, man, that thing, I don't want to walk on the road because I'm a person. Maybe I'll say that costs a little more, and then it'll kind of redirect me on the sidewalk. And so the plan is eventually for us to be able to put like all sorts of traits on this thing. Say, like, I care about like hills. I care about like not walking through this area of the city. I don't want to, like, maybe I'm on my bike and I prefer to go on bike routes. There's all sorts of things that we're going to hook in here to make like a highly configurable path planner. And so today's task is trying to like hook in the bus. So blue lines on here are all of the bus routes. And we have connections here where we say, like, here's a bus loop in UBC. Here we've kind of like connected these bus routes to the normal graph through these yellow lines. The line picking is not perfect. Sometimes it'll do something like a little bit abnormal. Like it'll say walk into the middle of the street to get onto the bus. It's like, well, that's not right, but that's okay. We can solve that later. What I'm more interested in today is trying to figure out how do we determine when we should get on the bus, right? And so I just want to like hook this up to the path planner at all, right? See how that works. And so the plan of action there, I think, is like, we know at some point we're going to look at bus schedules. That's going to be an important thing, right? And so you can we have this like intuition that calculation of when you should take a bus is going to be different than calculation of like how you should walk, right? When you're walking around, you kind of like look at the graph and you say, like, how far are these things from each other? And maybe you're gonna like multiply by some like attributes of the thing, like, oh, I don't want to walk down alleys, or like I don't want to walk uphill. But these are all kind of like distance-based metrics, right? The bus is going to be very much like time based, right? So you're gonna have like a bus schedule, and you're gonna get on the bus, and you're gonna say, like, well, I know that the bus is supposed to get to the next stop at this time. Maybe there'll be some variation for like traffic and stuff, but like generally you're gonna be using some sort of like time based system. And so I think I want to start by saying, like, give me street neighbors and give me bus neighbors, right? So like the way that like the calculation works is, like, I like plan a path. We can turn on like debug path planning, right? Basically, like, I will look. We're using A star. At each point, I'm going to like look at the things around me, and I'm going to say, like, I think that this is like the most likely path, so I'm going to walk that way. We calculate like a cost for walking down that road, and basically as the cost grows, we just keep picking what we think is like lower cost. And so part of this is by like you look at your neighbors to calculate the cost of your neighbors. And so I think that what we want to do is we want to say, get me my normal neighbors over here, and I'll do like the normal cost things here, the normal distance-based cost over here. Get me bus neighbors over here, and then I will do some sort of like time-based lookup or something. Don't really know yet. So step one, get transit neighbors. Then I think that we're going to let's get some win here, because we've kind of been at this for a few days and we haven't really got like a major win yet. So I want to see, like, let's plan a path. We'll just say that the buses are like 10 times faster than walking or something for now, and then we'll at least be able to see it tell us to get on the bus. Then I want to start looking at like, in order to like integrate schedules, we're going to have to know what time it is. So if I'm like starting over here, right, and I'm like, and we're saying like we want to take the bus, we're gonna have to like walk over here, and we're gonna have to know when we get here, right? And that's gonna be some sort of like distance times time thing. And what makes it this a little more complicated is that like if we have like score costs, like saying like sidewalks are better for us than roads, then all of a sudden like our score and our time to get there are like a little bit different. So we're gonna have to track those separately. So we'll probably integrate some sort of like, this is how fast I walk, and we'll have to track like the real amount of time elapsed versus like the like cost time elapsed separately. And then if we get through all that, then we can start trying to hook up like, okay, so this bus gets here at this time. Does that mean like, well, we'll need to do some sort of lookups to say like, oh, well, it'll take like under like 10 minutes for the bus to get here type shit. Yeah, that's the plan. That's the plan. Let's fucking jump in. Apologies for the long explanation, but I think more context is useful generally. I'm a big fan of dump all context and then have everyone else get mad at me for being like, what the fuck are you saying? I just asked you like for like a 5-word explanation of what you're doing. I'm like, let me go back 10 years ago and tell you the whole context of my life story and how I got to this point. like How I Met Your Mother, when he's like, let me tell you how I met your mother. And then it's like, I was in college one time. And it's like, dude, you didn't meet her for like another like 15 years. What the fuck are you talking about? Okay. So get transit neighbors. Get transit neighbors. Okay, so the way we've stored this stuff is kind of like, it kind of lends itself to easily extracting this information. So we kind of like collect data from a bunch of different sources, right? We have transit data from TransLink, we have street data from OpenStreetMaps, and we like ask OpenStreetMaps for all of the data, and it gives us this like big ass XML file, right? So if I look at like, you know, here we have like, here are some nodes, and the nodes are connected by ways and stuff like that. And there's like stuff in here that we don't really care about, right? We don't care about this version field. We don't care about like many nodes aren't like connected to roads. They could mark like buildings and stuff. And so we pre-process all this stuff by walking this XML, taking all of the nodes and sticking them in like nodes buffer, nodes, right? And then we kind of like intelligently prune these things so that we're only getting the nodes that are for each ways, and we store them like in order of how they're iterated in roads so that like neighbor access is like cache friendly. And then eventually we store like ways. And ways are like connections between nodes, right? So if you have a road that goes through points A, B, C, this will get like an A, B, C here. And then these are like separated by like a max int, and then like D, E, F will be over here. So you kind of have like these markers. Now what's kind of nice here is that we iterate all of the OpenStreetMap nodes first. Then in here, we're like, okay, now bus nodes. So we can kind of like segment whether or not a node is a bus node or a map node based off of like, is its ID greater or smaller than like 150, right? Probably more like 600,000, but you know what I mean. Like there'll be some threshold where we can say, oh, this is a bus node. And then we also kind of do the same thing here. We have like ways, bus ways, i.e. like between stops, the bus took this trip, this ends up here. And then at the end of this, we have bus connections, or yeah, connections we'll call it, i.e. like where we connect onto the bus. So the yellow lines in the thing we were showing earlier, right? Like these yellow lines end up at the very end of the list. And so if we're trying to make an API that's like get transit neighbors, and that's different than get normal neighbors, we can kind of say like, if my node ID is less than, like if this is like 150, we can say if my node ID is less than 150, then I look at these, right? If my node ID is greater than 150, then I look at these. And if I think that's it. And then for like normal neighbors, you kind of do the same thing where you're like, if I'm greater than 150, then I look at these ones. If I'm less than 150, then I look at these ones. So I think that all of that should kind of like lend itself pretty nicely. I think probably what I'm going to do is I'm probably going to like, how do I say this? So we have like a little bit of extra information here, right? We know that every single bus node will have bus neighbors, right? And we know that every single I guess every single bus node will also have non-bus neighbors, because I think that the bus nodes are bus stops. So you're at every stop you're going to be able to leave, get on the street, or you're going to commute to some other stop, right? So every bus node is going to have both a bus connection and a non-bus connection. Now, the vast majority of nodes, normal nodes, will not have bus connections. And so I think that what I want to do is I want to say like my node to node lookup is going to be like an array. Every single node has neighbors, and so storing those as like one big contiguous chunk of memory makes a lot of sense. Because then you don't have to eat like hash map lookup cost for these things. You can just jump to like a specific area in memory, bing, bang, boom. Same for bus nodes to bus connections, and probably bus nodes to non-bus connections. Probably all three of those can be stored contiguously in memory. Now, the ones that shouldn't, I think, be contiguous are nodes to buses. And I think in that case, probably a hash map makes sense, right? Because the ratio of like how many nodes there are to how many neighbors there are is going to be very low. So I think that we'll do like a hash map of node IDs, and that should probably work out, I think. But we will find out. So we have this like node adjacency map thing here. And I think we just want to extend this a little bit. We want to extend this to kind of say like, let me think for a second. Let me think for a second. So we want like node to, or OSM to OSM storage, I think. Then we're going to have like transit to OSM storage. No, transit. Yeah, transit to OSM, transit to transit. I think that's what we said. And then the other thing is going to be OSM to transit is going to be a stood auto hash map of something to something. I don't know yet. What thing to what thing? Dude, someone just drove past my apartment just absolutely blasting music. And it's like, maybe like, I don't know, turn it down a little bit. You know, it doesn't make you cool to just like fucking force that on everyone else's ears. It's a Honda? Probably. So this is going to be a map of node IDs to node IDs, I guess. Yeah, I think this makes sense. Okay, now here what we were doing before was we were kind of storing this stuff as like node 0 has neighbors 1, 2, and 3. Node 2 has neighbors 1, 3, and 4. And then we would kind of say like, okay, index 0 is the start of the indexes for node 0. And then we would store like 3 to say like, please look at this position for node ID 1. And then we would store like 6 after to go to the end of the array, something like that. Right, so you would say like, these are like the start of the segment for each of these. So I think we want to do something similar where we have like segment starts, like OSM segment starts. And this is expecting us to pass in takes OSM node ID. So invalid to pass bus ID here. No, that's not true actually. That's not true because we said that all OSM nodes will have OSM neighbors and all transit nodes will also have OSM neighbors. So this is actually going to take in this is valid for all node IDs. Okay? Which means that we don't need transit to OSM storage. This will live in kind of like, we'll just call this to OSM storage. That makes sense to me. Then we have a separate transit storage, and this is going to be the same thing. We're going to have a transit segment starts, but this is only going to use, this is going to take in takes transit node ID minus transit start ID, and valid only for transit nodes, right? So the idea here is that we have a contiguous bunch of transit node IDs. We're going to jump into this array at these positions for these, and we know that they all are going to have neighbors. So this is fine. Then this is the tricky one, and this is just going to be takes valid Valid only for OSM nodes. Perfect. I think this makes sense. Am I a car guy? No. I don't have my driver's license. I'm a 30-year-old man with no driver's license, which is maybe not good, but it's also not really caused me any problems that I've noticed yet. Because living in a city, you don't really need it that much. The only times where I feel like it might have been a problem is like if I ever want to go on vacation to somewhere where I would need a car. But also, you know, we also have like the nice benefit that I don't really understand traveling because I'm like a fucking idiot. And so that problem just also doesn't ever expose itself. It's a perfect solution. The perfect solution to having problems is just to ignore the problems, right? If I go, I would want in this scenario, just stop wanting that scenario. Perfect. Okay. So this is gonna be a disaster. So I think that we can kind of do whatever the fuck we were doing before, right? But we can kind of just only populate OSM segment starts and OSM storage to OSM storage. And I think that that will be basically whatever we had before was already doing that. So let's maybe just kind of build and just, this is going to start falling the fuck over and we can just kind of figure out where that is. So no field name storage. Okay. So here we initialize. Oh, interesting. Oh, fuck me. Okay, so okay. How do I explain this? So we had this concept of like for each node we had in our node adjacency map, we say for each node we have some data that is associated with it, right? And for each node we have these neighbors. We were kind of abusing that to say that like in our A star, we wanted to store a score for each node for each neighbor. And this is because for momentum based lookup, right? Usually you would store like one score for each node in A star, right? You'd be like, this is like 0, this is 1, this is 2, right? Because like, you know, maybe this is 1.5 because it's like, this is kind of like the distance it takes to get here by the shortest path. But with momentum, we get this kind of like weird fucked up scenario where the score for your next node changes based off the direction you came from. So we actually store scores for each node pair because now like this score is low if we're coming from here, but it's high if we're coming from here because we have to like turn a lot. And so we end up kind of storing our points for like pairs. So that like as you walk forward in the node, you can like look back and like, what was the score to get to this connection? Then I can like use that to tack onto this connection. And so all of that to say, we were storing scores for each pair of points, which kind of just perfectly mirrored the structure of this node adjacency map. And we just fucking like abused that and we pulled the like inside of this guy out and used him here. Now, I think that we're actually kind of lucky in that this OSM segment starts kind of has like the same properties. And the storage size is gonna have the same properties. So we can kind of just like kind of yoink the same thing, I think. OSM segment, I think. Because the OSM segment starts are all bus nodes and all OSM nodes. So I think it's fine. But in reality, we should write like a generic type so that we don't have to do this, like abuse. Okay, so now we have to kind of figure out all of this stuff. So our builder was kind of just taking node neighbors. So when we were feeding our builder, how do we feed this guy? Let's look at app.zig. We kind of like walk the index buffer once. Parse index buffer. And as we walk it, we like feed this like node neighbors thing. So we look at each way. So this is all of the, well, I actually don't know what these are. Ways comes from itnext, which is an index buffer iterator, which goes over index buffer, and is index buffer like cropped at all? Index data, is index data cropped at all? Where does this come from? We to look from the metadata end nodes to end ways. No, okay. So this is all sets of connections are iterated here. And every time we see any list of connected points, we feed our node neighbors. Got it. So here we're gonna want to be a little careful. Here, our iteration will eventually, we need to split this based on if on transit versus non-transit segment. Maybe we do that now. Maybe we do that now. So I think that the trick here is that we'll split our index buffer up a little bit. So this is kind of like all connections between nodes are marked here. But we can kind of get a little crazy, and we can probably kind of figure out how to split this shit up. I think that makes sense. So here, maybe we have like 3 sets of index data. This is going to be like OSM to OSM. This is going to be OSM to transit. No, this is transit to transit. And this is OSM to transit. And then we just kind of have to be a little careful about how we split this stuff up. So we'll say, let's do this. Const index data. We'll kind of just make this whole thing like a slice of U32s, right? And then we can split this up based off of here our index data. This is the OSM to OSM is going to be the index data subsliced from 0 to metadata dot metadata.sake bus way start index. Okay. Yes. Then the transit to transit is the same, but we go from this to whatever was in metadata. OSM to bus way start index. Boom. This needs to come from metadata, I guess. And then the OSM to transit index data is from whatever we did before to the end. Yeah, there we go. And so now if we go, don't need to incast, it coerces to size. Yeah, I think you're right. I would have had, but I don't know if I would have put the incast without it before, but maybe I would have. It does look fine. It does look fine. Okay, so now when we parse the index buffer, we can say that we're passing in the OSM to OSM. Okay. And so now we can call this OSM to OSM index buffer. And then we use this. Whoa, way lookup builder in it. Ooh, that's not good. Okay, here's what we'll do. Sorry. There's an important thing there. I just don't have the like mental energy to explain exactly what it is right now. I'm just going to say that in some cases, we want to use the whole index buffer as a whole. So this will get the whole thing. Fine. It's because like we do some things on like we look up tags based off the way ID, and so these like tags need to be probably relative to anything. Actually, I don't know. Maybe we don't. I'm gonna go back and look. Maybe that's fine. So ways, where does this get used? This gets converted into a way lookup. So this way lookup, we do look at like bus ways and connection ways. Yeah, okay. We do use this to draw the buses and the connections, which is maybe not correct, Maybe this should be, maybe we should like segment the way lookups as well to be based off type, but I don't think we should. So we'll do this. Index buffer. Maybe we'll call this num ways. And then this can, no, he stores the whole thing. Fine. So then we will just make sure that when we are walking, where does the iterator come from? Here, for now, we'll walk the OSM to OSM index buffer. Okay. And then I think everything's fine. So now we will this is only feeding OSM to OSM neighbors. That's what this whole thing was about. Which means that here we want to pass in data index buffer and the OSM data. But this is split data like this. Okay. Index, what do we call it? I thought we called it index buffer. Am I high? Index buffer. I guess I didn't save. I don't know, man. I don't know. Okay. So now when we build this thing, we're feeding OSM to OSM, which is great. Very great for us. And so now externally we don't need to change anything, I think. Yes. Maybe. What else is being used here? Here we say, we also say that we are feeding ways here. Feeding ways. No, this is a problem. I'm gonna change the way we do this. It doesn't work. Undo. Undo. All right. Here's what we're gonna do instead. I changed my mind. So where the fuck we were splitting data before? Split data. Let's leave that the way it was as well. I've changed my mind. And what we're gonna do instead is we are just going to keep track of which one we're iterating at. That makes more sense. So kind of just fuck everything we did in here as well. Sometimes you write some code just to find out that it sucks. And I think that that's fine. As long as you get to the point where you realize it sucks. That's the key. You have to make it there. Okay. Back over to where we walk the nodes. So this is going to be feed OSM to OSM. That's fine. And then we try to call this thing. It's going to be feed OSM to OSM. If way ID is less than metadata dot something. Do we have the metadata? I guess here we'll just, that's fine, it's fine. If the way ID is less than the busway start index. Yeah. Then we feed OSM to OSM. Yummy. Shut the fuck up. Every time I say anything related to eating, my instinct is to say yummy after, which just means that I say yummy after. If you say yummy, you say yummy. If you think of a shot. Dude, I'm losing my mind. Okay. So that's fine. Now we just have to figure out what we want to do with the rest of the stuff here. So here, what we used to be called storage we're coming from our build. We have node neighbors. This is going to be OSM to OSM neighbors is what we're building here. We kind of build this thing by working through a hash map first, and then a hash set. A bunch of hash sets. Then we turn the sets into arrays later because we like don't need the hash set after we build the thing. So that's kind of why we do it this way. So OSM to OSM, OSM to OSM, OSM to OSM, 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 OSM. I feel like I sound like a sim. OSM, you know, when they speak like Finnish. Okay. So now we're chilling. when we build with OSM to OSM node neighbors. Everything gets named OSM to OSM. Now, this becomes also boom, boom. OSM. This is OSM segment starts. And to OSM storage. Okay. Now, the rest of these things will just kind of like zero initialize for now, just to fix the compilation, and then we'll kind of get back to the rest. Is this a speedrunning stream or what? I guess there's a lot of similarities. I don't know if I would say that it's exactly a speedrunning stream, but I like the comparison. This is gonna be what? Stood auto hash map node ID initialize with an allocator. Okay, then here this is OSM storage to OSM storage, what we called it. This is OSM segment starts. Then what else is in here? All this shit. All of this shit. Womp. Womp womp. So these get alloc freed. This gets alloc freed. And what's happening here? This gets self dinit. Boom, boom, boom. All right. Neighbors. So this is going to be now renamed to like get OSM neighbors. Okay. Maybe using the word OSM everywhere is not great, but it's not. We'll live. So this is two OSM segment starts here. So segment starts, and this is two OSM storage like this. Okay. Anywhere we're using get neighbors before, this is get OSM neighbors. Okay. Where else is he complaining? So this is get OSM neighbors, get OSM neighbors, get OSM neighbors. Get OSM neighbors. I feel like a sim again. Okay. So here, this feed OSM to OSM actually is just feed to OSM, right? Because it's technically legal for us to pass in the bus to OSM connections in here as well, based off of the way we stored this stuff. And so everywhere we wrote OSM to OSM here, actually should just be two OSM node neighbors. That's not spelled right. Two OSM node neighbors. Womp, 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 womp. There we go. Hey, what do we do here? We write code. We write code. We are working right now on a map. We're working on a map. So the idea is that I want to replace Google Maps because it pisses me off when it tells me to go the wrong way on the bus. We, I think, just got to a point where it should build enough for us to try opening it. So let's kind of see if that is true. And let's just see if we run. Okay, so that's a really good sign. So it looks like nothing heavily broke with the kind of changes we just made. So can we still path plan? We can. There is a red line, and he is moving and grooving. So I think we're in a good state to start adding in the addition of node neighbor, of bus neighbors. So here we're going to say feed a to transit. Okay. This is going to take it away. That makes sense. And what are we going to do with it? I don't know yet. So before we were saying, let's see. So how does this feed work? Self to OSM node neighbors. So we go from, I see. So the way is going to have node IDs in it. Right. So this is like a list of nodes that we're connecting. And so here we need to check whether or not this is a transit to OSM connection or a transit to transit connection. And instead of doing that, we can just write it down. So we'll say feed transit to transit here. Yeah, that makes sense to me. And here we'll say feed OSM to transit. Okay, so in this case, feed transit to transit. We said that we're going to do basically the same thing that we were doing before, where we have transit to transit neighbors. This is again just going to have like a bunch of array lists. Now, why is this? What is the storage format here? It's given a specific bus stop. Who are my adjacent bus stops? Right. And so these bus stops could be connected through many different paths, right? And so we store a hash map here. Well, in Zig, like you make a hash set by storing a hash map to nothing. And so the idea here is that if we see the same neighbor twice, we do not count it twice. That's why this is a hash set here. So we kind of do the same thing as we did before, but we just store it in the other hash set. So here we have to make that hash set. So this is going to be transit to transit neighbors. Boom. Okay. And then what? Then what? We store it here, transit to transit. I guess calling this transit to transit neighbors is fine. And here, when we feed transit to transit, we're going to iterate over every single node in the way that was given to us. But we've said that our storage format is going to be indexing into these arrays at transit node ID minus transit start ID, which means our builder has to store transit start ID. Like this. That makes sense, which means that here we need to take in like transit start node ID. Transit start ID is fine, I guess. And then here we store transit start ID. Okay. Then when we feed transit to transit, we just loop over this shit. I guess we need an arena allocator for some fucking reason. Right, because we are working with these hash sets and we're using an arena to speed the fuck up. Now here, this is where we get the node ID, and only on the key do we subtract, I think. So we want the like real ID of the thing stored, but the fake ID used as index. So this is going to be minus self transit start ID. And these are not to OSM, these are transit to transit. But we still store the real ID on the other side. I think that makes sense. We will see. It will become apparent very quickly whether or not this is like fucking crap or not. Okay, so now let's when we create this thing, we are going to say that we are passing the metadata dot bus node start index, I think is what we were passing in here. This being a node ID is probably going to help just with my own confusion. So this should take in a node ID. And then here, when we use this thing, we're going to write dot value here because it's strong type, which is fine. This expects a node ID, so we will say value is equal to this. I know it's kind of silly. We're not actually using the strong type anymore. It just kind of feels like it helps me. Maybe that's silly. Okay, so now here we can say else if way ID value is less than metadata OSM bus to waste, OSM to bus way start index. Here we're feeding a transit to transit. Feed transit to transit. Nice. Okay, and we can test if all of this works correctly by trying to draw all transit neighbors, I think is what I'm going to do here. So in our renderer, I think right now we intentionally draw the bus routes separately. I think we do that somewhere. We'll find it. Here. Here we draw all of the bus routes. So I'm just going to not do that, right? So if we build this right now, if we do zig, build, and this, we should see the bus routes not rendered at all on the map, I think. Failed one compilation errors, right, because the fucking benchmark app is broken. Instead of fixing it, I'm just going to get rid of the benchmark app for now. Just for now. We will live without the benchmark app for a little bit. Okay, so now if we go and we look at like the area, like this like UBC bus loop. Oops, I just kind of like fucking fucked that up. So the UBC bus loop is actually so much harder to find without all that stuff. But I think it's here. Here it is. Right, so we have the bus stops and we have our connections to the bus stops, but we don't have the bus stops rendered themselves, which is good. That's intentional. And I think what I want to do here is I want to just check if the bus neighbor lookup is working. So in fact, I think actually, no, it's fine. We haven't done the OSM to bus lookup yet, so it's fine. So what I want to do here is I want to go like app zig. Maybe on initialization, we will walk all nodes. Yeah. Let's do this. So we'll say for node, where is our like point lookup points? No, num points. Yes. We are going to do something like point lookup. Thinking. We need to draw all the lines. So if we want to draw all the lines, we're going to make an index buffer with all the indices of nodes that are connected via this trait. So we have to do some sort of like adjacency map. Does this not have like a fucking type? Hello? Unknown? Why? Is it because like it doesn't compile and so it like doesn't get that far? No. Weird. But we know what it is. It's a node adjacency map. So here we want to call get transit neighbors, which doesn't exist yet. Okay. Now, here we're going to look to see if the node is less than the transit split, because we have different maps for if we're a transit node or not. And so for that, we have to store the same transit node ID here. Sure. Which means that here we need to propagate that thing. So when we build, I think I'm going to get rid of this init function and just kind of like put all of this in build directly. I think that'll be easier to work with. And then here we will use, self arena child allocator. That makes sense actually. A child allocator like this. And then we can use alloc here. 2 OSM node neighbors. So this is a self.2 OSM node neighbors. This is, we need to populate the transit stuff now. Dude, my cat loves the Rube Goldberg machine. Hell yeah, dude. I like it too. I can't stop looking at it. Okay, so for self to transit, whatever the fuck, neighbors, we append to transit. We need to make this same thing. So this is storage is now, this is 2 OSM storage. Boom, 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 boom. Then we have OSM segment starts. Okay, and then now we have to do this same thing, but for bus to bus. I guess. I don't know, man. I like there's something so fun about like not really planning out where we're going and just kind of like following whatever path we end up on until we get there. There's something really fun about that. I don't know if this is like ideal in any way, shape, or form, but it's definitely fun. Okay, so now here we go over the transit neighbors, and we append to the transit segment starts, and we use the transit storage, and here we append to the storage. Okay, that seems reasonable to me. And so now the 2OSM gets 2OSM storage. This gets OSM segment starts, and then we get like try to transit. Hello, transit to transit storage to owned slice. This is the wrong thing. This should go here. And oops. To try or not to try. Shut up. Transit segment starts. There we go. Okay. So, and then transit start ID is equal to self transit start ID. Propagate that shit onwards, baby. All right. Okay. And then does this stuff like have to get de-initted? How does that work? I guess we de-init the builder. We do. Okay. Easiest way to learn, best way to learn things, the easiest way to shoot things at yourself in the foot a million times. Yeah, I used to think really strongly against this type of working. I remember when I was like a young developer, I would see someone I knew, would kind of I considered them like a really good worker, but then they would spend like 4 days just like sprinting in like the wrong direction. And I thought that was like really bad. But now I think I do that a lot, but I also kind of feel like I end up going where I wanted to go a lot of the time anyways. So I wonder if there's like some like level of experience that you need in order to cut the path off early that I like haven't articulated well. Right, I guess I kind of like just like kind of running somewhere, but like eventually you kind of start to see like you start to feel like, oh, this doesn't work. And I guess you just need to know when to stop. But otherwise then it's fine. Okay. So when we get our transit neighbors now, we can look at the node and we say if node value is less than self transit start ID value. In this case, we look up in HashMap. Otherwise, we look at self transit to transit. Boom, boom, boom. So the segment starts are still fine. So yeah. So we look at transit to transit segment starts. And these values are subtracted by transit start ID value. Okay. Sure. Then here we call transit to transit storage from start to end. And then here we say unimplemented. I guess we will instead return empty for now. Fix me. Look up in HashMap. Okay. That seems fine. That seems fine. And so now we can do... Wait a second. Am I supposed to push an extra element on the end? I am. Ha ha ha. Good thing I remembered. So the reason that we do this is because I profiled this at some point. And so before we were kind of storing it like if you had like node IDs like 1 and 2 and 3, you would store like 1 starts at 0, 2 starts at 5, 3 starts at 10, right? But the length of the array is like, there's kind of like an implied like length of the array at the end here. And so we had like this if condition to be like, well, if we're out of bounds, use the length of the array. Otherwise, use this index stored in thing. And it turns out that's just faster than or slower than just like tacking on 1 extra element at the end of your like ID, your like index list or whatever. what stack am I most familiar with? I don't really know what people mean by stack. So it really did, like if you expand on what you mean by stack, I can answer. But yeah, because like I think stack is very context dependent, right? Like I've worked a lot with like firmware and kernel and like, you know, C++ user space app. Web dev? Oh, none. I'm just not familiar with any web stack. I have no idea what the fuck I'm doing. But we figure it out. We figure it out as we go. It's kind of the fun. Okay, so we now theoretically have a way to get our neighbors. So we go back to app zig, and somewhere we were looking at the point lookup, and we were saying for each point we want to look at our transit neighbors. Yeah. Const transit neighbors is the adjacency map. Get transit neighbors. Yeah. Sure. Yeah. Why not? We say if transit neighbors len is equal to 0, continue. Otherwise, we want to draw this shit. So if we want to draw this shit, we need to basically, we are using this thing called like primitive restart index in OpenGL. So you would like attach a buffer to OpenGL that has like a bunch of lines. You have like 50 lines, and each line has like an unknown number of segments. So you just stick like a max int in between the segments, and then OpenGL goes like, oh, okay, new line time. And so what we're gonna do is we're gonna have like a buffer of indexes. We'll call this like transit neighbor EBO buff. Element buffer object buff. It's a buffer if you think about it. We are going to push a 0xFFFFFFFFFFF. I feel like the longer I stream, like not like per day, but just over time, like kind of like the more like unreasonable my communication is getting. Just spamming 0xFFFFFFFF there is stupid. But what you can do. I guess I want like bit casting here is a little equally. Let's do std math max int of u32. This is WVP stack, right? WASM vanilla Python. Perfect. I guess it technically is. Yeah, we have WASM. You could call it maybe the you could also throw a Z in there somewhere. But I guess technically like the thing that's running in the website is WebAssembly. So yeah, WebAssembly, vanilla, and then the Python web server. I guess you could also swap out that web server for anything. But yes, we are using WVP. WASM with a Z. Perfect. Okay, this member function expected 1 arguments, found 0. Am I fucking high? Oh, because I need to pass in the non ID. That's a really good point. Thank you, compiler. Okay, so now we append the max int. This needs to be a var. We need to de-init this thing. And I guess I don't really use scopes very much, but I should. So we should kind of scope this shit. And then here we're going to say that we have like an actual element buffer object. So we're going to say like const ebo is equal to GUI create buffer. And then at the end of this, we're going to bind this shit. So we're going to say like GUI GL bind buffer as a GL index buffer, element array buffer. Okay, we're going to bind ebo. And then we're going to say GUI GL push GL buffer data. Nice. We're gonna push that shit into element array buffer. And what are we gonna push in? We're gonna push in a pointer, a length, and a usage. So the pointer is going to be transit neighbor EBO items pointer. The length is gonna be transit neighbor EBO items len. And then the usage is gonna be like GL static draw, I think. We're not gonna change this shit. We are not going to change it. So we will say static. If it's static, it's static. Don't forget to defer DINIT. I think I did here, right? I think I did. I don't think I'm missing one. I might be, but I don't think I am. So now here we just say append slice of the transit neighbors. Bing, bang, boom. Bing, bang, boom. Okay, so we expected const u32. Missing defer. Oh, thank you. we would have found it, but it would have pissed me off first. What is he angry about? Expected type U32 Zig build check. What's he bitching about? Oh, because I's a U size. Fine. Fine. If you're gonna be like that, Zig, I'll fucking allow it. Because I actually really like the fact that ints don't cast automatically, but sometimes it's like, I wish they did this time. We're gonna do an evil trick here. So, transit neighbors is a bunch of node IDs. This is expecting a bunch of U32s, but you can kind of just, since the node ID is just a strong type of a U32, I can just pointer cast this and say, like, don't worry, it's the same shit. But it's not the same shit, and that's really bad. But it's okay. It's okay. This wants U8, so this is times 4. And then looks like it's fine. So now we need to like do something with this thing. So we're gonna call this like transit EBO. We're going to store that over here. And then we're gonna like, when we render, we have to use that thing somewhere. So I don't know. Yeah, compiler, I know what I'm doing most of the time. I think that it's like, it's that we have like massive hubris, right? Like we're like, please don't get in my way is kind of more what we're saying. It's like, let me shoot myself. Please, compiler. Not that way. Not, don't demonetize me. Just like, I'm only shooting myself in the foot. But I guess I'm kind of asking it to let me shoot myself in the head, like a little bit. Like, let me do what I want. Function render. Okay. So now we have to like just kind of bind that EBO and render it. So I think we can just actually do like GL draw elements here with GL line strip. We need count, which we don't have. So we're going to say like, what is it? Self transit EBO len. We're going to have to store this. We haven't done that yet, but we'll figure it out. Then we need the type, which is GL unsigned int. And the start, which is 0, I think. Offset 0, yes. Don't let me shoot myself in the head, but maybe just like me point it there every once in a while. Yeah, perfect. Okay, so we need transit EBL, and we also have to bind this thing. So we're gonna say bind buffer of self transit EBO. And I think we have to bind it as gl.element array buffer, if I remember correctly. And I think that's probably fine. We'll see. So now we just have to set transit EBO len. And so we just need to, somewhere, wherever the fuck we initialize this thing, here, we're just gonna say var transit EBO len is equal to 0. And then here we will say transit EBO len is equal to the number of elements. I don't know if it's number of elements or size in bytes. I think it's number of elements. I think. We will see. He doesn't compile because we didn't propagate that thing. Transit EBO len equal transit EBO len. Boom, bing, bang, boom. We build. Let's actually build now. And then let's run. Fmap, please. I would like to run my fmap. And that's a really, really good sign. That really does look like bus routes. So if we go back here and we look at this stuff, we are seeing that like every bus stop is going. I think this is right. I think this is right. These like the blue lines are kind of tracing where I think the bus routes in the city should go. So yeah, really good sign, really good sign. So I think that means we're tracking the like transit neighbors correctly for transit. And now we just have to tack on the other part of getting from the street. So that's wherever the fuck we walk our stuff. Where we walk our stuff. Where we walk the index buffer. We just need to add one more if statement here. That's else we want to feed a OSM to transit. Okay. So the expectation here, feed OSM to transit. So what did we say we were going to do here? I think we said here that since this is a very infrequent thing, we are going to store this as just a hash map of node ID pairs. Feed OSM to transit. Yeah, what does it even need to be? Like hash map. So we want to look at, given an OSM node ID, give me the transit node ID. Right. So this is going to be a hash map of OSM to transit neighbors. This is a hash map of node ID to node ID. Simple. It's simple. And then we have to create that thing. So the OSM to transit neighbors is equal to OSM to transit neighbors. It doesn't exist yet. Here we're going to say OSM to transit neighbors is equal to stood auto hash map from node ID to node ID init with allocator. Probably with the arena allocator, to be honest. Right? Because like we're going to free all this memory later. Are we? I don't think we are. I think we're going to use the actual allocator. Because I think that the data in this shit is like we since this hash map is going to be used directly, we don't have to like copy stuff out. Because it matches the data format we're going to end up with, which means that on dnit here, we need to say self OSM to transit neighbors dnit, I guess. And then what we're probably going to do is when we build, we're going to, here, we're going to say like, OSM to transit is equal to self OSM to transit neighbors. And then after we do that, we can say self OSM to transit neighbors is equal to a new array, auto hash map ID to node ID. So the idea here is that when we don't want to deinitialize the like actual memory because we're actually going to send this away now. And so we on the dnit call, we want it to like, if we fail and we dnit, then we free this memory. But if we don't fail and dnit, then we don't free this memory is kind of what I'm trying to get at here. Okay. Now, expected statement found pub. Oh, because I'm not in the right spot. That's true. That's a really good point. Okay. So what does this do? Self OSM to transit neighbors. Here we need to figure, so here we want to assert that the way node ID's len is equal to 2. We expect this to be a mapping of single node ID to single other node ID, OSM to transit. I shouldn't go like this. It makes me look like like, is this what Trump does? He does like this, right? I don't remember. And I look just like him. Then here we need to figure out which node ID is which. So we're gonna say that the OSM node ID is the minimum of way node ID's 0 value and way node ID's 1 dot value, right? We are assuming here that the OSM one is like below some threshold and the other one is the other one. If you think about it. What is the other one? Transit node ID. So this is just max. And then here we can even assert that the OSM node ID is less than the transit start ID value, and that the transit value is greater than or equal to that. And then we can say that the OSM to transit neighbors put OSM node ID transit node ID. Now this is a little odd because there could actually be multiple transit neighbors per OSM node. So actually stashing this as 1-to-1 is fucking stupid and brain dead. Stupid and brain dead. The name of my album or something. I don't know. I was gonna say sex tape, but that doesn't make any fucking sense. So this is gonna go from this to array list, I think. right? So we're gonna say, hey, maybe we need a new thing in here. Maybe we don't. Who fucking knows? Which now makes me think that there is going to be some sort of conversion from like builder state to usage state, right? Because here we don't need the array list kind of signals that this is like a modifiable thing, and it also has a bunch of extra shit attached to it that like once we're finished generating this thing that we don't need anymore. So that's why we kind of split this builder up, which means that we can go back here and we should use the arena allocator here now, because if we are going to delete this stuff later, we can just delete it as part of our like big ass hunk of memory that we don't give a fuck about. Okay. This guy now needs to also say array list. So I should really be using type defs, but shut the fuck up. Right? And then when we feed this thing, we are going to not just blindly put something. We are going to say OSM to transit neighbors. Get entry, I think, at OSM node ID. Does this give me... No, I kind of want like a get or put. Get... Oh yeah, get or put is what I want. Get or put is what I want. When I get a good case to use comp time in Zig. What do you mean? I don't like, are you asking when will you? I think there's lots of good opportunities. There's lots of times where you need to like pre-calculate stuff. Okay. Like for example, sorry, I'm getting distracted. If we look at std debug, is there like std log debug? Here, their format is comp time. Wow, you can do compile time validation of this. Iterating anything, iterating like any types, any type of like reflection. That's pretty good. I don't know, man. So if this is this failable? This is probably failable. Res dot hello res dot. Why isn't this auto completing? Unused local content. Res dot, here we go, found existing. If we did not find anything, we need to populate it. So this is going to be a std array list of node IDs initialized with our arena allocator. Self arena allocator. Boom. Okay. And then here we can kind of unconditionally be like res value pointer append. Except I guess this should also be a hash set. Let me think about this for a second. I think if we get a duplicate in here, we can tell them to go fuck itself. I don't think there should be a duplicate in here. I don't think. We should have a one-to-one mapping here. So it's fine. It's fine. Okay. So I think this is fine. This is fine. Now, I mean, in general, because it's not 100% clear when you need it, I think that you will, I think that you will find it, right? Like, I think don't worry about it, right? I don't think, like, comp time isn't, like, it's exactly the same. It's just the same code. And so I think if you're, like, generating some stuff at compile time, you're generating a list of values that you want baked into the thing. You want to like do some sort of data conversion based off of data that you have in compile time, you'll use it. And if you don't need it, then you don't need it. And I think that's like fine. I wouldn't worry about it. I wouldn't worry about it. I want to learn programming with which first language to choose. Hell, I mean, here, we'll just solve the problem for you. Python or JavaScript. Done. And I think in reality, just pick, right? I think getting stuck in like decision paralysis, there's no point, right? One of them will be fine, right? Like anything that you try will teach you to program. And that's really the more important thing. I'm like, keep in mind that when you apply for jobs that you'll need to like, you'll need to pick a language for that job, and you should study up on the languages for the jobs that you're applying to in advance, blah, 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 because like, you know, people who are interviewing like are, I think, overly focused on that. But like in reality, it's like they're all the same, and people will get mad if you're saying that, but it's close enough. Like like anything in like the imperative programming languages. Fine. Why is JS or Python? Learn C first. I think that if you learn C first and you've like never programmed before, you're gonna shoot yourself. Like it's like it's there's I think it's harder to pick up. But then again, I think there's things in Python and JavaScript that are hard to pick up. I don't know, man. I don't know. I think the vast majority of people don't learn C first. I would suggest C first if you want to get into systems programming, but like I think that if you're like, how do I write a function? Starting with C, you're just gonna like cause problems for yourself, right? All right. This is fucking broken. Feed OSM to transit. Feed OSM to transit. Why is this complaining? Oh, because I just had to refresh. Okay, so here, this needs to be stood array list like this. And actually, now when we build this thing, we actually are copying out. So how are we copying this thing out? What does our final version look like? Our final version looks like a hash map of this to slices, which means that we're gonna have to like make those slices. So we're gonna say like const OSM to transit. This is gonna be like a new hash map that is no longer array lists. No longer array lists. Okay, we are not using array lists here. And I'm saying that a lot of times because I'm trying to convince myself that it's true. Self arena child allocator. This is the allocator we want to use. I guess we're just calling it alloc at this point. Alex can help me out a little bit here. This is going to be like this. And we're going to say for each of these guys, I guess we're going to need to like iterate this thing. So how do you do that? OSM to transit neighbors, iterate this. Iterator. Iterator. We want an iterator. Yeah. Okay. So we're going to iterate over the things in our original array. Don't learn a language, learn a program, pick a project and language, and then learn that to do project and language. I agree with that. That's true. That's true. That's why I said Python or JavaScript, because I kind of thought that covers everything that you would want to do as a beginner. But you are right that you should call that out explicitly. While we iterate this thing, we're going to have like some entry, and we are going to convert each entry from an array list into a slice. So we're going to say our output thing is this. Okay. That makes sense. This expects another argument. What does it expect? Key. He does want a key. That is a really good point. Yeah, then we don't have to do this. And what is he complaining about? This is const, so he needs to be variable. That's fine. This is also seems like it should be fine. I don't know what he's pissed off about. Seems fine. Expected type this chunk of crap. Found type this chunk of crap. Oh, because I didn't write const here. Okay. And then when we free this stuff, it's fine because it was attached to the arena allocator before. This to-owned slice is going to be a fucking problem. In fact, I think all of these are going to be problems. How is this not a problem right now? To OSM storage. Oh, that's why. That is why. I see. So this we have to be very careful here. This to-owned slice is going to allocate with the original allocator, which is bad. Like, because that's the arena. We don't want to use the arena anymore. We want to use like our allocator. So we should say instead of this, we want to like to-own. Can we like? Is there like a to-own slice type shit with like a new allocator? To-own slice. I mean, we could just copy it ourselves. Clone? No, that uses the same allocator. Insert slice. I mean, we could just copy it. That's fine. We'll just copy it. So this is going to be alloc dupe. Entry value pointer items. And this is a bunch of node IDs. And we'll say duped is equal to this, and then we duped here. Use unmanaged array list. Oh, that's interesting. That's clever. I can see how that would work, but I'm not gonna do that. And like error, defer, alloc, free, duped, etc. Fix me. Error defers here, not quite right. Like this stuff needs to be managed somewhere, but it's fine. It's fine for now. Okay, so now we that way you have to pass an allocator to show and slice. Yeah, I get that. I think it's like maybe sketchy a little bit because I don't know if like that to own slice might try to free the existing memory in the array list with the allocator that you pass in. Because I think to own slice, well, I guess it does to own slice. Yeah, I'm not really sure what it does there. It might be a little wacky. So I think that this is safer, right? There's no reason to worry about this. Okay, so I think that if we did everything right, we should be able to now those, when we were drawing those blue lines should also be drawn for node to transit. So if we go into renderer, here we draw yellow lines somewhere here for connections between the transit segment and the OSM segment. And so now if we run this now with that commented out, we should see blue lines connecting those things if everything is hooked up right, which it probably isn't, but it might be. So let's kind of go back to the bus loop there because that's like our kind of go-to testing case. And it does, I do not believe, oh, no. So this line here should be drawn in blue and it's not. So I don't really understand why that's the case. So let's kind of go figure that out. Get transit neighbors. Yeah, that would do it, huh? The fact that we don't return anything does mean that we don't return anything, if you think about it. So this should be self OSM to transit get node. And this is get or else return this thing. An empty array. I think that's right. All right, let's try again. I should fucking auto-initialize this window to be way fucking bigger. Still nothing, right? This still isn't being drawn. So the question is, why the fuck not? Why the fuck not? OSM to transit. So are we pushing to this thing? Push transit, feed. We are feeding OSM to transit. So this is if we're below the OSM to bus way start index. Okay, so we should be, let's I guess we breakpoint here. Zig build and then we GDB args this and then we breakpoint this and we run. And we are feeding this thing. And that's not right. Break. Can we break on this? Okay, yeah. So we are running this section of the code. And so we can go to the build section. Whoa, what the fuck? Maybe that breakpoint didn't work the way I thought. So we can go here and let's just kind of like look at what we get when we try to build this thing. Why are you typing exclamation point LinkedIn? What do you think you're gonna learn? What do you think you're gonna learn? You're gonna learn that I'm unemployed. You're gonna learn that I have no job and I stream on Twitch. He wants to hire you. Oh, when you put it like that, I shouldn't make fun of him. Okay, so OSM to transit size 2,000. Are there 2,000 bus stops? That might make sense. So this has some shit in it. Can we look at like what is like in this thing? So we have like unmanaged. Were you in Google previously? Dude, why do people... I don't want to make too much fun of people, but I mean, a little friendly making fun is fine. People come in here and ask that sometimes, and it's like, what a specific question. What a specific question. Like, the chances of that being yes are so small, right? Are you looking for someone who specifically worked at Google? Or is it, are you just like guessing that because I know how to program that I did work at Google? Like, I just don't understand the question. Like, what is the reasoning behind the question? I don't understand it. Just because it's so oddly specific. Because I assume that you fit all the stereotypes. I don't... That's hurtful. I don't... Fuck. Am I a fucking coding bro? No, people are saying fair in chat. No, this isn't the stereotype I want. Savage, yeah, dude, that hurt. That hurt. If you weren't trying to hurt, then don't worry about it. I'm just joking. Like, it's fine. But that's funny. Okay. So what the fuck is going on here? So we have OSM to transit node. So when we get transit neighbors, are we just not calling this where I think we are? Also, you fit the stereotype cool streamer. Okay, we don't have to be fake and nice here, okay? You can tell it like it is. So we are looking at every single set of points, are we? So for point lookup num points, we say, hey, I'd like my neighbors, please. And so this must include the node. So here, can we maybe like look at what we're returning here? So here we'll say, if we don't get anything, then we will still return this empty thing, but I will say, I guess we'll say nothing here. Then we should say every once in a while we should get something that the lookup hits. If it hits, it hits. So here we should be able to say like std log debug got return of size this. And this should be ret.len or something. Maybe. And then here we return ret. So here I'm kind of hoping to see that like we see that log printed and he sometimes gets things of size 1. Okay, yeah, so that's good. So then the question is, why the fuck am I not seeing them drawn? Right, that's fucking weird. I guess we could maybe try to look at the values of this. So we can say, first mapping. So we can kind of say like this goes to this. And this is like the input node ID, node value, and the output value, which is ret0 value. Because there should always be at least one. At least one. Okay, so we are seeing mappings of things like this. Now the question becomes if I am not seeing these mappings appear in the rendering, then that kind of indicates that there's like something weird going on. So here we have, this goes from node 303537 to 626857. 303537 to 626857. So that's also really good. Like, this is really indicating that that line should be there. So now the question is like, why the fuck isn't it? Because as far as I can tell, we are doing this lookup and we are getting the value that we expect. So maybe we can like look at even. Get transit neighbors. I wonder if this is fucked. Could be. Could be. Yeah, it's really fucking weird. Really fucking weird. Transit EBO. Transit EBO len. This is the length of the buffer, which again kind of makes sense. I wonder, it could be that like, I'd be interested to say, like, if transit neighbors 0 is equal to, what do we say? 303,537, I think. Then can we, like, std log debug appending any and, like, just, like, write what the fuck we're writing down? Okay, and then we'll kind of go back into the... Does stdlog debug print to std error or std out? I think std error. You can hook up a log function though to do whatever you want. So in WebAssembly, we print it to the console with our like hand-rolled console callback. But I think by default, std error, I think. What was I trying to do? I was trying to remove that fucking debug log that we put somewhere else. This one. Okay. And we'll fix the number if it was wrong. It was, hello, where am I? Where am I? Who are you? What day is it? 303,537. What did we write? 537, 537. 303, 537. Okay, so this is kind of interesting. So here, when we called get transit neighbors, we did see, oh, we need to append our thing too. We are drawing lines of 0 length. So when we append to this slice, we actually need to append I every time. And we're missing 1 point in each of these things. Ha-ha! Ha-ha-ha-ha! There it is. Okay. God. Sometimes off by 1 errors, I don't know if you guys knew this, but sometimes you get hit by off by 1 errors. And, you know, sometimes they get you. All right, let's try again. There it is, baby. Let's fucking go. That's a blue line if I've ever seen one. Okay, sick. So now what we have is we have a bunch of connections between, yeah, we have everything we need. We have everything we need. So get transit neighbors API done in an hour and a half. So there is a really good chance that we do not get to time integration. In fact, I can guarantee, because if this takes even just 15 minutes, I'll stop. So we will get to planning a bus route just assuming that the bus is fast. Because I think the bus might be fast. Okay, so we've got a lot of leakies. Leakies and cheeky leakies. So this is coming from map data zig 222. So this is, right, this stuff, which makes sense. So it's just when we de-init this, we need to for self var iterator is equal self OSM to transit iterate value iterator, I guess, is fine. For IT while IT next, we have like some item and we like fucking alloc free the item. Boom. Let's see if that fixes it. Fuck. Why is he mad? What's he complaining about? Expected pointer found slice. Oh, do I have to dereference this thing? Interesting. Interesting. Speaking of two-step in comments saying you can override by writing std options log function in your root source file, what do you guys think about the pattern in the Zig standard library of like checking if root has, right? Like this idea of this, like in my praise of Zig for being pragmatic, this makes a lot of sense to me, right? Like the idea that like, look, like you need to override things in the standard library, throw it in the root, and if it's there, we'll use it. And that makes sense. But like something about it feels like a lot of the pitch that I've heard around Zig is like the fact that like the no hidden control flow argument, right? Things don't change automatically. And this just kind of feels like it's getting into the range of like magic to me, where you just throw a std_options in the root source file and it's like, yeah, that does stuff. And it's like, I get it, but part of me feels like it's like wrong, but I also don't have like a better option. So it's like, what am I complaining about? If I'm like, I don't like this, but also there's nothing better, it's like, well, shut the fuck up. So I was just wondering if other people had different thoughts. What am I doing? What am I doing? We were checking that we had no leakies, and we did not have no leakies. We did not have any leakies. We had no leakies. So I think we're back onto kind of this. Plan bus routes without knowledge of schedule. Okay. So in our path planner, now when we say like get OSM neighbors, when we do our step, what's going on here? What is going on here? So we run our thing in a loop when we run the path planner. We iterate by steps. That makes sense. We look for our neighbors and we iterate over those neighbors and we update the neighbors. Where update neighbors does like a bunch of like A* cost stuff. Okay. Then for our neighbors, what do we do with neighbors? Why does this exist? Oh, for no reason. Just for an assertion. Okay, sure. So we iterate these things and we update the, right, so we update the cost to get to each neighbor because it's very easily calculatable at this point, right? So we're kind of like going like, hey, I go from here to here, then here to here, and this guy has like this neighbor, and this guy's like this neighbor, and this neighbor. So I start here, cost is 0, and then this node is like 3 long. So then I come over here, and when I get to here, I go, oh, the cost of this guy's 3 plus straight line distance to the end. And so like when I investigate this guy, it's like a really good time for me to check this. And so then when I iterate this guy and I say, hey, cost for him for all of my neighbors is straight line distance heuristic plus the cost to get to the thing, right? And so what we are going to do is, I guess we are going to do the same thing here where we kind of look at like our bus neighbors, right? That's going to be important in some way. Seems like it'd be tough to make it more explicit without sacrificing DX or of just log function, but I agree it does some kind of magic and hidden. Yeah, okay. I think then it just sounds like we're like you're on the same page as me, where it's like it's nice, so you need to have it, but it does feel weird. But like, what are you gonna do? Okay, makes sense. Okay, so we're gonna look at the adjacency map. We're gonna look at get transit neighbors for our current node. Okay. And for each neighbor, I don't know if we're going to do the same thing. Because the cost, so this is like, I am on the sidewalk and I'm about to get on the bus. So I'm going to calculate the cost to get to that guy. Okay, so probably what's going to happen is there's going to be some sort of like, the actual like cost to get there is going to change. It's going to be different, but the updating of the thing, maybe this whole thing just gets duplicated. I think that's probably fine. That's what we're going to do for now. We're going to call this update OSM neighbor. And then we're going to copy paste this and call it update transit neighbor. And we're just going to kind of like fucking tear this shit apart. So I think, does this neighbor needs to be an A* node? It probably does. We'll see in a second. But I know that like turning costs, we don't really give a fuck about turning costs on the bus, right? we're not using momentum on the bus. We're just trying to like, you know, get on, we get on. Which means that this like point is not used, the neighbor point, which is fine. Which kind of means like all this stuff isn't used, which is also fine. The cost, we are going to use distance, I guess, but I'm going to multiply this by like bus multiplier for now. Right? So we're just going to kind of like say bus go fast zoom zoom now, man. Right? So the node cost is get the current cost to get to me. The tentative score is my cost to get to me plus the cost to get on to the bus. And right now we don't really have costs associated with individual buses either. You maybe could do that. You could maybe we should allow that, because you might be able to say stuff like I think that the bus number 25 is like my favorite bus, so I'm gonna like weight that one a little lower. I guess that's like something you could do. So we'll leave that in. That seems fine. Neighbor entry is we look for the neighbor. That's fine. If the tentative score is 2 gig, then we go okay. We assign the tentative score. We calculate the F score, which is the tentative score plus the distance of the neighbor to the end times the min cost. So this all looks sane as well. Now, I think that there's an argument here that there is some stuff that feels pretty duplicated and is error prone, is more what I'm worried about, right? I'm worried that we're going to add a feature like something like get cost here. We're going to maybe update the tentative score calculation, and we're going to miss parts of that if we do it on one path and not the other. So I'm going to put a fix me here and be like feels error prone to duplicate this with update OSM neighbor. And I'm going to do the same thing down here, because I'm just like not 100% sure that like there's not, I don't see it right now. I don't see the way that we fix this, but I want to think about it. So I'm just going to put that fix me in there, and then we'll track it later. Then we update the neighbor, we add it back to the queue as something that we want to look at. Okay. So now our previous update neighbor, where the fuck that was, step here. We just do the same thing here, but for the bus neighbors. And it's just the loop now becomes bus neighbors. And it's not update OSM neighbor, it's update bus neighbor. Transit neighbor. And I think that does it, to be honest. We'll see. It might not work, but if it does work, that's really fucking cool. Okay, so if I'm like over here, and I'm like, bitch, I want to go, fuck. Okay, panic no neighbor. Interesting. Find my neighbor index. Ah. Hold on. Okay, so. Oh, find my neighbor index. Find my neighbor index is failing. Why? So I am looking at my adjacency map. Oh. Ooh, hold on. That's not good. So this is the adjacency map. Sorry, I'm thinking. Ah, fuck me. Fuck me. Okay, so earlier when we were talking about the fact that we reuse the format of the node adjacency map to store scores, that doesn't work, because the node adjacency map says like, hey, I am a bus. I am a node in the graph, and I have neighbors A, B, and C. And then we also have like a transit neighbor, D. So the format of this thing is supposed to be, for this node, we store A, B, C, D. And we store these in like a chunk of like large amounts of data. And then we write down like the start and end index of this thing. And that's how we know like which neighbors are ours. Is like we like look at this big buffer at this range. we were saying before that like we were we were using the same thing. Instead of storing neighbors here, we were like kind of like duplicating this buffer to score like the scores of how expensive it is to get to that node. So we're saying like 50, 60, 70, 80, right? Now the problem here is that D is not in this list because he's orange. We don't store the orange nodes in this array that we're copying from, which just means that we have to make our own, which is fine. It just means that like we were kind of like reusing the calculations of how many nodes there are for each thing by copying them from like the node adjacency map. And now we can't really do that, which is fine. It just means that we have to figure it out ourselves. Which is also kind of like, this was like kind of bullshit. Like this was bad. This was guaranteed to happen, right? I have like, I have like, this happens to line up with the storage format, so if we yank the return data, and like it just felt wrong, so it's fine. We'll just recalculate segment starts. So how do we do this now? Instead of copying from here, we have to figure it out ourselves. So we still use the node adjacency map. We just say for adjacency map to, like, does this guy like kind of expose how many nodes there are? Not particularly, but we can kind of cheat again. We will cheat for now. So we'll say const num nodes is the adjacency map to OSM storage.len. And we'll just say like hack. But it's fine for now. And then we will kind of like we'll say const var segment starts is equal to stud array list. No, this is just like a raw alloc. So we know that this is going to be the length of num nodes plus 1, I think. Okay. All right. Now the storage though is actually kind of harder. So var storage is a stud. I guess what we'll do here is we don't actually have to store anything in here right now. We're gonna pre-jack the storage to be empty. I think we kind of like assume that whoever calls this is going to populate these things with whatever they want to populate. So here we just kind of have to count basically how many of each type of neighbor there is. So we're gonna say for 0 to num nodes, we are going to say adjacency map get OSM neighbors, I guess. Oh, okay, say const node ID is a node ID is equal to value is equal to I. We're gonna say like, hey, we have this many OSM neighbors. So we're gonna say like, let me think. We actually have to store the node IDs in here too. Hold on, we're missing something. How do we know which node is which? How do we know which node is which? I guess this has to be like a struct now that goes like data is a T. I guess we'll see like the storage and node ID. Which now we're maybe getting into the range of this doesn't make sense anymore to store all of the node IDs again. That's probably why we were using the adjacency map before. Find because when we were doing find neighbor index, yes. We were saying like, hey, we have a neighbor 4, so node 10, neighbor 4, it might be like node ID 100. And we were like looking into the node adjacency map to figure out what those were going to be. And now that the node adjacency map doesn't contain that info, now it's kind of weird. Okay, it's fine. We're going to keep doing this for now. I'm not 100% sure that this is like makes sense, right? I'm not positive that this is better than like a hash map anymore. So we might come back here and like profile it and see if like different storage formats works, but this will work fine. This will be fine. So we'll call this like neighbor IDs or something. How else is this used? Everything in the A star node lookup is using like neighbor index, not neighbor ID. So I think it's probably fine. It's probably fine. I don't fucking know, man. I don't know. I don't know. We'll see. Okay. So we will say like neighbor IDs is an array list of node ID in it with an allocator. Okay. Sure. What's he mad about? That this is not a type. This is a value. That makes sense. We are going to delete these things later. And this makes sense. This makes sense. So for each node, we're going to say that we neighbor IDs append slice of this, as well as get transit neighbors. Okay, yeah. This makes sense. This makes sense. And this is not I, this is node ID here. Because these expect node IDs, which is fair. And then what? Segment starts at I is equal to neighbor IDs items len. Okay. This makes sense. This makes sense. Segment starts at num nodes is equal to the final length. And then here we have neighbor IDs is equal to neighbor IDs to own slice. Okay, we need an error differ here on segment starts. It's all coming together, guys. It's coming together. Now he's mad about something here. We'll just incast. This is fine. Error unit is ignored. So both these need to be tried. Okay. This also needs to be incast, which is fine. And I think that's it. Storage is no, this is the wrong length now. So this has got to be segment starts is equal to segment starts. And this length is now neighbor IDs items len. Okay. Okay. So now this is fine, but now everybody who uses them is going to be fucked. So this is going to be const also, to be fair. This is no longer reference. On dinit, we need to alloc free self segment starts as well as neighbor IDs. All right. There's also like potential to share these across A star lookups. So we should think about that a little bit, right? Because like if we're using this for both like scores and came from, we like they're gonna have the same indexes. So this is actually like really fucking stupid. So should definitely share these across A star lookups. But for now, we are just starting with something. We always start with something, and then we come back later. Now, I think now it's just that they find my neighbor index just needs to use, instead of adjacency map, we want to look at like G scores. What is this called? It's just called G scores. I don't know why it's not auto-completing. Oh, I guess we still use the adjacency map? No. No, we don't. We look at this, and we look through neighbor IDs from... It's like something like this. Hold on. Segment starts me dot value. Yeah. End is me value plus 1. And then we iterate neighbors as neighbor IDs start end. Oh, it's the other way around. Find my neighbor index finds me relative to my neighbor. So this should actually be neighbor.value. Here and here. Okay. And so then we look for the one that is me. Does that work? It might. It might not, but it might. Wait, okay, okay. Oh, wait, we're not path planning yet, which is where this would fall over, huh? So if I'm like, you know, I'm like here, and I want to go like, fuck! Okay. Panic index out of bounds at 253. OSM segment starts node.value plus 1. Oh. This seems like it should be fine. I don't understand why it's not, to be honest. We will see. So he's mad. He's not happy. Frame 9, like frame 8. What's going on here? B node 629537. This is that long, which is weird. How many nodes are there supposed to be? Can we look at like p self points? Points dot points len over 2. This is how many there's supposed to be. Okay. So there are 629537 points in the points buffer. And now we are trying to index out of bounds on that. So why is that happening? That's kind of weird. That shouldn't be happening. So right, like the maximum node value should be 629536. And so who is causing that to happen? Okay, so this node ID is fucked. And this is coming from our initialization. Oh. Because the length of the thing that we're referencing is already padded. It's intentionally padded. So num nodes is this -1. And this is what we get for fucking hacking. Am I right? This is what we get. We deserve it. We deserve it. So now, start path planning, still fucking sigboarding. Still not working great. He's still doing it. He's still doing it. Why? Why? Num nodes is this. Zig build, and I'm missing something. I am missing something. Start path planning. Backtrace. Frame 8. Up. List. Print num nodes. Whoa. Whoa. What the fuck? What? That's a big number. That is a big ass number. Which feels wrong to me. Feels wrong. So can we like dereference the adjacency map? Like what's going on here? We have adjacency map 629538. This makes sense to me. 2 OSM storage. Oh, we're fucking idiots. We are idiots. This should be the segment starts. Segment starts, not OSM storage. Let's try that. All right. Let's get a little bigger. Let's get big in here. Okay. He is now kind of working. It's crashing still sometimes, and also extremely slow. So why? Why? I guess in some cases we are still missing. No, OSM neighbors and transit neighbors should cover everything. Okay, so we should probably first debug the crash. That will give us a clue. So here, I just kind of go like, I'm going to start path planning, please. And if I go over here, that sure is slow as shit, but it is at least following the path. Now, as soon as I get to a bus street, that's when it starts fucking itself. So that's a good clue. Good clue. So frame 6, frame 7. So P, where am I? So we are at line 281, which is here. Right, so I have got some transit neighbors, and we are failing to find them. Now the question is, why? Print current node ID me. So this is 443813. Is this before or after the split from, you know, the bus way start ID, bus node start IX is what I want. Okay, so this 443813 is below the bus node start. So this is I am a non-bus node looking at my neighbor, a bus node. I'm trying to get onto the bus, is what is happening here. So we should see neighbor is definitely above the bus threshold, so that makes sense. Now it doesn't make sense is why find my neighbor index is not working. Okay? So let's kind of look around. Okay, so we want to look at neighbors. Okay. So can we look at like pointer, like dereference this thing at 2? So we want to see the 2 values. So these are supposedly the 2 neighbors of my neighbor, which are both above the bus threshold, right? 624814. So the neighbors, my bus neighbors don't know that I exist, which is kind of weird. So it kind of indicates to me that when I call get transit neighbors over here, when I'm constructing this thing, it really, or get OSM neighbors. So the bus get OSM neighbors, it seems like is not populating correctly. Interesting. So this is, I wonder if we can find this bus location. It's gonna be really hard to look that up. Okay, so we can maybe study for a second. So here, it's got to be this get OSM neighbors. So when we push OSM neighbors, when we feed OSM to transit, we only push one way. So we also need to do OSM, so self to OSM node neighbors at transit node ID, put OSM node ID. And we probably need like the self arena allocator here as well. I think that's probably it. Put requires an allocator and a key and a value. So I think here we just write void here. Ah, man, debugging is so fun sometimes. 2 OSM node neighbors takes a node ID. OSM node ID needs to be, a little bit of a little casty wasty. That's Leo. Thanks for the gifty. Thank you. That's very kind. Very kind. Just want to let you know that you have more viewers than Soulja Boy. That's a funny metric. I mean, no offense to Soulja Boy, but I mean, I haven't heard about Soulja Boy for a long time, like maybe 15 years. So maybe that kind of makes sense. Good evening to I'm confirmed Goose. I'm scared to read that because I don't know what it says. I don't know what you mean, and now I'm concerned that I am a problem. So here we have neighbor. So I think now we have this problem in the path planner where he's kind of he has indexes that are like outside of the OSM neighbors, which is a problem. So he's kind of assuming that he can use get OSM neighbors everywhere, and he can't really. So let me think about this. So came from point, where is this used? This is used in, this is used for the momentum stuff. So here I'm saying, hey, I am updating an OSM neighbor, but I am a bus stop. So the momentum of getting off the bus also doesn't make sense. So it's almost like we need another version of this, depending on if we came from the bus or not, or we can just set the turning cost to 0 in that case. Let's try just dodging the problem for now. So here, oh, we already handle it here, where we say, hey, if we're out of bounds, then like, fuck it, just use yourself, which means that here we can also kind of do the same thing. We can say like, if, I guess we'll just comment this out. I think if I just comment out this assert, honestly, I think everything just works, which is like fucking brain dead and stupid, but I think it's right. I think it's right. We will find out. Actually, I guess we won't find out. We will just kind of like prove, we will just kind of like guess if we think that it is correct or not. So here, we could kind of see that as I get far, it should trend to taking the bus. Which I don't know if it is, to be honest. It's kind of hard to tell. I mean, the fact that it's following the grid does kind of indicate to some extent. Right? Like, no sane path would take, like, this. Right? So, the fact that that's happening makes me think that it's working to some extent. Right? Like, it was definitely taking... I wonder if we can, like, find where the fuck that bus is. Is it this one? No. It would be, like... Why can't I highlight that thing? Hello? Highlight the fucking... Highlight the bus stop. Highlight the bus, please. Give me which bus route this is. No, I'm just fucked. I will never know. I will never know. That's kind of funny. Am I not allowed to highlight bus stops? No, I am allowed to highlight some of them. So I don't know why. I don't really know why, but okay, let's just try again. Let's try again. So let's kind of like start at the bus loop. Right? This is like kind of like a cheating case, but it's fine. Oh yeah, that's got to be working, right? So we'll see if we can get it to take this blue line, this like diagonal blue line. Ow, 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 everything hurts. Ugh. Ugh. It's so slow. Okay. I mean, something feels wrong to me. Right? Like the fact that I couldn't get it to take Oh, maybe it's not supposed to take that one. Maybe that's fine. It's kind of really fucking hard to tell. But we are at least boarding the bus, right? Like, this is very clearly him trying to take a bus over here and then a bus over here. So maybe it's not... It's far from perfect. It's slow as shit. But I think it's doing something. I think that it feels like there's some bugs in here, right? Like here it should, I would think that it should choose to take a bus that goes this way. But we're on the right track. We're on the right track. I'm going to look at this a little bit off stream because I don't really know where I want to look first. And then also we're gonna have to take this a little farther anyways to look at like trying to plan according to schedule and stuff. But I'm pretty happy with that progress. That's pretty cool. That's pretty cool. I'm gonna look at this off stream, try to figure it out a little bit, but it looks like it's working to some extent. It's at least like not like super fucking wrong. Which is pretty sick. Pretty sick. All right, guys. Thank you for watching. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. The first little bit is what we call happy hour, where we don't do feature development necessarily, but we work on like small things, maybe like cleaning up some of the code that we ended up doing today. Would we clean up tomorrow? Sometimes we do like a little bit of rebasing, a little bit of refactoring, a little bit of maybe small feature development. So if you want to check that out, that's on Twitch and Patreon at 12:30 to 2. Then we have like the main stream, which is this. From 2 to 4, which gets archived on YouTube. So if you're on Twitch and you want to check that out, we should see links in the Twitch description for that stuff. So if we look at the links, we've got YouTube, Discord, GitHub, and Patreon if you want to check those out. What else? Like, subscribe, Twitch Prime, you guys know the dealio. And I think that's all we usually plug. I can't remember, man. I don't know. Let's say bye to YouTube, and Twitch, let's find someone to raid.